What is a z-score? A z-score tells us how many standard deviations any particular item is away from the mean. So if I'm looking at a bunch of students taking exams and getting GPA scores, the z-score will tell me, if this is the mean g-score, say it's the GPA score is supposing it's 3.0, the z-score will tell me how many standard deviations this particular student is away from the mean. So for that, to know how many standard deviations this student is away, I need to know the standard deviation, not only the mean. So let's actually have an actual example here. And what we're going to assume that we have students taking a statistics exam. Let's just say, for argument's sake, their scores are normally distributed. They don't have to be. And the average score for this exam is 75 points. And the standard deviation, the amount of spread, is going to be 10 points. And then we have one student who has a score on the exam of 65, which is here. The student's got 65. And there's another student that took the exam and got a score of 95. So it's up here, much higher score. So the z-score for this student is how many standard deviations are they above or below the mean. And in this case, we can see that this student is 10 points, which is exactly one standard deviation below the mean. And because it's below, we're going to put a negative and a 1 standard deviation below. How about this student over here? How many sets of 10 are they above the mean? That will take us to 85, and that will take us to 95. So this student is above the mean, so their z-score is going to be plus because they're above the mean. It's going to be plus 2 because it's 2 standard deviations above the mean. Is there a formula to help us work that out? Indeed there is, and this is the formula for z-score. It's going to be x, which is the student's score, minus the mean, divided by the standard deviation. I'll just put ST for standard deviation. In this case, the mean is 75 and the standard deviation is 10. So for this student, what is this z-score? Well, it's going to be x. The x for that student is 65 minus the mean, which is 75, divided by the standard deviation, which is 10. So 65 minus 75 is minus 10, divided by 10 equals minus 1. Now, in this case, the numbers were relatively easy, so we could have picked that out. But sometimes you may not be an exact number of standard deviations or above or below, so it's better to use the formula. Let's look at the student on the other side. So again, we're going to apply this formula for this student here. So x for this student is 95. And we're going to subtract the mean, and then we said that the mean for this student, well, for this class is 75. And we're going to divide that by the standard deviation, which is 10. 95 minus 75 is equal to 20. Plus 20 over 10, which is equal to plus 2. And that's exactly the same value as we had here. And this is exactly the same value as we had here. But as I say, the formula here is more useful when you have odd numbers, like the standard deviation may have been 10.7 and this student may have got 64.8. So it's not as easy to see or calculate, and in that case you'd use this formula over here.